Welcome to solverfy.
Problem on the friction and lifting force. Now look at the diagram shown in the board. Okay, we want to determine the force speed that will be able to lift the 20 IV load. Okay, of course, to solve this problem, we must understand that this problem involves a general bearing and it's a pulley mounted on an axle. So the first thing to do is to determine the what we call the friction circle radius and apply equilibrium to the system, okay, and solve the problem. So that to get the friction circle is arrow F, and I've indicated it in the diagram there, is equal to arrow, which is the radius of the axle, sine the angle of kinetic friction. Okay, and we can get the angle of kinetic friction from the relation arctan of the coefficient of kinetic friction. So it's given in the problem. When you plug it in there, you're going to arrive at a value of 11.31 degrees. Okay, so that will give you the angle of kinetic friction. It's given there. The mu for it there is given, so just plug it in. Then we can now come plug it into our this equation to get the friction circle radius. So arrow is given in the problem to be 1 inch. So when you put it there, you're going to want is given to be, sorry, the diameter of the axle is 1 inch. So half of it is 0.5 sine our 11.31 degrees. So when you solve that, you're going to arrive at a friction radius, circle radius of 0.098. Okay. Now, if you look at the circle, you see that the load, the reaction force there, the force arrow there is coming to the left side of the center there. So that tells you that okay, it's coming to the left side of the center. Okay, that tells you that if you want to take moment, this other side, if you want to take moment about this other side has been short already by that amount of the arrow F. Why for the other side of the other side of the circle of the divide, we will have a gain of the RF. So that if we take moment about summation of moment about D that is there, we are going to arrive at something that look like this. So our P is going down, okay? So it's P times 6, which is the radius of the pulley that is given, minus that RF that we have calculated. When you plug it in there, that's what we're going to get. So that's the perpendicular distance, okay? Plus the weight is the weight times the perpendicular distance, okay? The weight will go through RF, arrow substitute F rather, okay? Plus the 20 IB load. The 20 IB load will go through a distance of, it will gain a distance of, that's the normal 6-inch plus the RF that we have gotten, okay? So you can now plug this into your calculator and have your answer. Do your manipulation, make P the solid of the formula, you arrive at 122.35. Okay, 35 over 5.902 5.902. So it's going to give you 20.35 20.73 IB. So that force P that is required is 20.73 IB. So that's it.